Hey kids, this is Mr. Cozy. This is video 31 where we talk about solving quadratic equations using completing the square. Now the question that I left you with in the last video is, suppose that we have something, a quadratic equation that we can't factor. What do we do? The method that you may think about right away is the quadratic formula, and that's a fine method, but the quadratic formula actually originates from the method that we will talk about today, called completing the square. And the nice thing about this method is that it shows up in a lot of places other than just solving quadratic equations. So this is something that we'll use elsewhere. So yeah, let's get started. I have a quadratic that I can't factor. I've moved everything to one side, and I've marveled at the fact that I can't factor this. So what do? Well, step one is to move the constant term to the other side. So plus 2 plus 2. So on my left side, I have my quadratic and linear terms, my x squared and x terms, and on my right side I have the constant term. And notice that I left a gap here because I'm gonna add in something right here in a second. Okay, here we go. Step 2. Take half of the linear coefficient square it and add to both sides. So my linear coefficient is right here. I'm going to take half of that and square it, and I get 9. So I will add 9 to each side. And what I have then is x squared plus 6x plus 9 equals 11. Let's change that to black, like my soul. Okay, next up. Step 3. The left side is now a perfect square trinomial. So factor it. Okay? X squared plus 6x plus 9 factors, and it factors beautifully. It factors, in this case, as x plus 3 times x plus 3. It factors nicely. So I'm going to write that as x plus 3 squared equals 11. Now I have a single thing, a single x. So step 4 is to solve using inverse operations. So square root. I'm going to have x plus 3 equals plus or minus square root of 11, minus 3, minus 3. These are not like terms, so I keep them separate. And those are my two answers. Okay? Completing the square. Let's take a look at another example. Let's take a look at x squared plus 5x minus 3 equals 1. Okay? Now, if I pull everything to one side, I quickly see that I cannot factor this. You might be tempted to say, hey, Mr. Cozy, how about 1 and 4? Those add up to 5, but these are factors of positive 4, and I need two factors of negative 4. These signs cannot be the same. If this were a plus, I could factor it. It's not, so I can't. So instead, I complete the square. I move everything to one side. I take half of my linear term and square it. Okay, this is going to be a little bit of a pain. Don't be afraid. It's not that bad. So half of 5 is 5 over 2. 5 over 2 squared, I square the top and square the bottom, is 25 over 4. So that's what I add to each side. Okay? Now, spoiler. This is going to factor x plus 5 halves. Whatever half of the middle term is, that's this term. Okay? In the previous example, half of 6, it is 3, and that's what we had. Down here, half of 5 is 5 halves, so that's what we have here. This is a feature of completing the square, is our whatever number that we have is half of the middle term. Okay? On the right side, I need to do an LCD of 4. So this is 16 fourths plus 25 fourths. It's going to be 41 over 4. Okay? Take a square root. I'm going to get x plus 5 halves equals plus or minus. Now, square root of a fraction, I can do square root of the numerator and square root of the denominator. It's very convenient. Minus 5 halves, minus 5 halves. And so I'm going to have x equals plus or minus radical 41 minus 5 over 2, because these have the same denominator. I could also write it as negative 5 plus or minus square root of 41 over 2. Either way works. Okay? All right. We'll talk about this more tomorrow. If you're a little confused, what I recommend you do is rewatch the first part of this video where I talk about the method, because the method never changes. Okay? All right. We're going to cut this off here. Have a great day, and I will see you tomorrow. Bye-bye.